All right, let's jump into another deep dive. This time we're heading beyond Earth to explore these fascinating ocean worlds, and particularly Jupiter's moon Europa.
Sounds good.
Yeah. Um, you guys have sent in some really incredible articles, including excerpts from Exploring Ocean Worlds Beyond Earth, the Europa Clipper mission, and I'm really excited to kind of dig into all this with you today.
Me too.
Yeah. So, some of the questions we'll be tackling today are, what makes scientists so excited about ocean worlds?
Yeah.
What is it about Europa that makes it such a prime candidate for finding life?
Yeah.
And what kind of mind-blowing tech will the Europa Clipper be using to unlock Europa's secrets?
It's pretty cool.
Yeah. So, for a long time, we were really fixated on finding planets within the habitable zone.
Yeah.
That sweet spot where it's not too hot, not too cold for liquid water to exist on the surface.
Yeah, definitely. That was the prime directive for a while.
Right. But, ocean worlds like Europa are kind of showing us that life might not need to be a sunbather to thrive.
That's right. Yeah. It's expanded our thinking of where life could exist. You don't need to be close to a star.
So we're moving beyond the Goldilocks zone, huh?
Yeah.
That's a pretty big shift in thinking.
It is.
But here's what I don't get. How can a moon so far from the sun have a liquid ocean at all?
Right. Well, that's where tidal heating comes into play. So imagine Europa caught in a cosmic tug of war between Jupiter's immense gravity and the gravitational pull of its neighboring moons.
Oh, wow.
This constant push and pull creates friction within Europa, generating enough heat to keep its subsurface ocean liquid even though it's far from the sun's warmth.
Okay, so it's not the sun's heat, but this internal friction that keeps things toasty.
Exactly. Yeah.
So we have Europa, this icy moon with a hidden ocean, potentially warmed by Jupiter's gravity. I mean, it sounds like something straight out of a science fiction novel.
It does. Yeah.
But what makes scientists think this ocean could actually support life?
Well, Europa isn't just some static ball of ice and water. There's evidence of plumes, like giant geysers erupting from its surface, hinting at a dynamic and active ocean interacting with the icy shell above. And if we look closer at our own planet, we find hydrothermal vents on the ocean floor teeming with life that relies on chemical energy, not sunlight.
Right.
Scientists believe similar vents could exist on Europa's ocean floor, offering a potential energy source for life to flourish.
Hydrothermal vents as potential hotspots for life.
Yeah, I mean, it's possible.
That's incredible.
Yeah.
And speaking of exploring those possibilities, let's talk about the Europa Clipper mission. This spacecraft is set to launch soon, and it's going to get unbelievably close to Europa, skimming just 25 kilometers above its surface.
Really close.
So what makes this close encounter so crucial?
Well, that close proximity allows for incredibly detailed observations that wouldn't be possible from farther away. The Europa Clipper will capture high-resolution images, analyze the composition of the surface ice, and even search for organic compounds, those essential building blocks of life. It's like having a high-powered magnifying glass to examine Europa's potential for harboring life.
Wow, it sounds like the Europa Clipper is going to give us an unprecedented look at this intriguing moon.
It really is. Yeah.
And unlike the Mars exploration, which is focused on finding traces of past life, the Europa Clipper is on a quest to find life that might exist right now.
Right.
I mean, that's a game changer.
Absolutely. It really begs the question, what would that life look like? Would it be similar to life on Earth, relying on familiar molecules like DNA and RNA, or could it be something utterly different, expanding our understanding of what life even is? The possibilities are truly awe-inspiring.
Okay, before we get lost in the mind-boggling possibilities of alien life swimming in Europa's hidden ocean, let's shift gears for a moment.
Okay.
Tell us about Titan, this moon with lakes and seas that aren't even made of water.
Right, right. So Titan is a world that challenges our assumptions about what life needs. Instead of water, its surface features vast lakes and seas of liquid methane and ethane, hydrocarbons that would be gases on Earth. It's a place that seems almost alien, yet it holds the potential for prebiotic conditions similar to those that existed on early Earth. It's a unique case that truly pushes the boundaries of our imagination.
It seems like every new discovery about these ocean worlds opens up a whole new universe of
It
question.
does.
But that's what makes it all so exciting, right? It's like we're on the verge of rewriting our understanding of life itself.
I think so, yeah.
Yeah, and the exploration doesn't stop there. Imagine future missions with landers touching down on Europa's surface, or even submersibles diving into its hidden ocean.
Yeah, that would be incredible.
I mean, it's a vision that might seem like science fiction, but the technological advancements are constantly bringing us closer to making those dreams a reality.
Yeah, for sure. I mean, we're already working on the technology to make that happen.
Speaking of pushing the boundaries of science, the Europa Clipper is packed with some seriously advanced tech. It has these things called spectrometers, and to be honest, I'm not entirely sure what they do. Can you break it down for us?
Sure. So imagine a spectrometer as a kind of chemical fingerprint scanner. When it analyzes light reflecting off Europa's surface, it can identify different molecules based on how they absorb and emit light. This tells us what the surface is made of, providing clues about what might be hidden in the ocean below.
So they're like chemical detectives searching for clues in the ice that could point to life in the ocean below.
Pretty much, yeah.
That's fascinating. And what about these mass spectrometers I've heard about? They sound even more complex.
Yeah. So mass spectrometers are like super sniffers. They analyze the chemical composition of a sample by separating molecules based on their mass. This allows them to taste the molecules present in Europa's plumes, potentially giving us a direct glimpse into the composition of its ocean.
Okay, so the Europa Clipper will be taking pictures, analyzing the surface ice, and even tasting potential plumes from the ocean.
Mm-hmm.
What kind of information are scientists hoping to find with all this data? What would suggest the presence of life?
Well, one of the key things they'll be looking for is organic compounds, those complex molecules that are the building blocks of life as we know it. Finding a rich diversity of organic molecules would be a strong indicator that the conditions in Europa's ocean are suitable for life. They'll also be analyzing the chemical makeup of the water, looking for specific elements and compounds that could provide energy for life.
So it's not just about finding any old molecules, it's about finding the right combination of ingredients that could support life.
All right, exactly, like a recipe.
That makes sense.
Yeah.
But here's something I've always wondered about. Jupiter emits a lot of radiation, right? Isn't that harmful to life?
Well, radiation can be harmful, but it can also be a source of energy. In fact, Jupiter's radiation actually interacts with Europa's icy surface, creating compounds like hydrogen peroxide and oxygen. And here's the kicker. These compounds could then be transported into the ocean below, potentially providing fuel for life.
So it's like Jupiter is accidentally helping to create the conditions for life on Europa.
In a way, yeah. It's pretty amazing.
It's amazing how interconnected these systems are. But I have to admit, I'm still trying to wrap my head around the concept of an ocean hidden beneath miles of ice.
Yeah.
What would it take to actually explore that ocean directly?
Well, that's where things get really challenging. To reach Europa's ocean, we'd need to develop technology capable of penetrating through the ice shell, which could be anywhere from 10 to 15 miles thick.
Oh, wow.
We're talking about ice-penetrating drills, autonomous underwater vehicles, and a whole host of other innovations that are still in the early stages of development.
It sounds like a monumental task.
It is, yeah.
But considering the potential rewards, I can see why scientists are so excited about the possibilities.
Absolutely.
But before we get ahead of ourselves, let's take a closer look at another fascinating ocean world. Enceladus. What makes this moon so special?
So Enceladus is another intriguing moon, but this time it orbits Saturn. Although it's smaller than Europa, it's incredibly active, boasting massive plumes of water vapor and ice particles erupting from its south polar region. What's really exciting is that the Cassini spacecraft actually flew through these plumes and sampled their composition directly.
Wait, so we already have a glimpse into what's lurking in Enceladus Ocean.
We do, yeah.
What did Cassini find?
Well, Cassini detected organic molecules, salts, and even tiny grains of silica, which suggests hydrothermal vents, just like those we discussed on Europa. And remember, on Earth, those vents are teeming with life.
So we have two ocean worlds, both with evidence of hydrothermal vents, both potentially harboring life as we speak.
It's pretty incredible.
That's mind-blowing.
Yeah.
But how do these discoveries change our understanding of habitability?
Well, it's a complete paradigm shift. It's no longer just about planets orbiting at the right distance from a star. We now have to consider moons, distant icy worlds with hidden oceans, as potential cradles of life.
Like our cosmic playground just got a whole lot bigger.
It did, yeah.
Yeah.
A lot more interesting.
Yeah,
And a lot more interesting. It's a humbling realization, isn't it?
it definitely puts things into perspective.
Yeah.
But let's not forget about our other intriguing ocean world, Titan. You mentioned it has these vast lakes and seas, but they're not made of water.
Right.
Can you tell us more about what makes Titan's environment so unique?
Yeah, so Titan is like stepping into an alternate reality. Instead of water, its surface features lakes and seas of liquid methane and ethane. Now, on Earth, these hydrocarbons are gases.
Right.
But on Titan, they exist in liquid form due to the moon's incredibly cold temperatures.
Wow, so we're talking about a world with a completely different kind of water cycle. That's wild. But can you have life as we know it in a place like that?
That's the million-dollar question. Life on Titan, if it exists, would have to be fundamentally different from anything we know on Earth. It would have to be adapted to those extremely cold temperatures and the unique chemistry of methane and ethane.
It's like a giant chemistry experiment on a planetary scale.
It really is.
But you mentioned earlier that Titan might have prebiotic conditions similar to early Earth. What did you mean by that?
So scientists believe that Titan's atmosphere, rich in organic molecules, might be similar to the atmosphere of early Earth before life emerged. And there's even speculation that there might be a layer of liquid water beneath Titan's icy surface, potentially creating an environment where those prebiotic molecules could interact and evolve.
So Titan might be a window into the very beginnings of life, potentially showing us how life could emerge in an environment vastly different from our own.
It's mind-boggling.
It really is, and it highlights the fact that we're just beginning to understand the incredible diversity of environments where life might exist. Okay, I want to circle back to the Europa Clipper mission for a minute. We've talked about the spectrometers and mass spectrometers, but what other tools will it be using to study Europa?
Right. So the Europa Clipper is going to be equipped with a suite of cutting-edge instruments. It'll have a camera system capable of taking incredibly detailed images of Europa's surface, revealing features as small as a football field.
Wow.
It'll also have a radar instrument that can penetrate the ice, potentially giving us a glimpse of the structure of the ocean below.
Wow, it sounds like the Europa Clipper is going to be like a Swiss Army knife of space exploration. But with all this incredible technology, there must be some limitations, right?
Right.
I mean, we're talking about a spacecraft traveling millions of miles to study a moon covered in ice.
Yeah, you're absolutely right. One of the biggest challenges for the Europa Clipper mission is the harsh radiation environment around Jupiter. The spacecraft has to be carefully designed to withstand this intense radiation, and the mission team has to be incredibly strategic in planning the spacecraft's trajectory to minimize its exposure.
So it's not just about the technology itself, it's about using it strategically and planning for the unexpected. That makes sense. But even with all the challenges, the potential payoff seems enormous. I mean, we're talking about potentially discovering life beyond Earth. What would be the biggest scientific implications of such a discovery?
I think finding life on Europa, or any other ocean world for that matter, would be one of the most profound scientific discoveries in human history. It would tell us that we're not alone in the universe, that life is not a fluke confined to our little planet.
It would completely change our perspective on our place in the cosmos, wouldn't it?
Absolutely. It would open up a whole new realm of scientific inquiry. We'd want to know everything about this alien life, its biochemistry, its evolution, its relationship to life on Earth. It would be like opening a new chapter in the book of life.
It's almost overwhelming to think about the possibilities.
It is.
But before we get too carried away, let's bring things back to Earth for a moment. I know we're talking about exploring these distant ocean worlds, but what are the practical implications of this research for us here on our own planet?
That's a great question. The technologies being developed for missions like the Europa Clipper have numerous applications here on Earth. For example, the ice-penetrating radar being used to study Europa's ice shell can also be used to study glaciers here on Earth, helping us understand climate change and its impact on our planet.
So the research we're doing to search for life on other planets could also help us protect life here on Earth?
Exactly.
That's amazing. But beyond the technological advancements, what about the philosophical implications? How does exploring these distant worlds change our perspective on our own planet?
Well, I think exploring other worlds helps us appreciate the fragility and preciousness of our own planet. It reminds us that Earth is a unique and special place, a true oasis in the vastness of space. And it underscores the importance of protecting our planet for future generations.
It's like looking outward helps us look inward, reminding us of what we have here on Earth and inspiring us to take care of it. It's a powerful message.
Indeed. And it highlights the interconnectedness of all things. The search for life beyond Earth is not just about finding aliens, it's about understanding ourselves and our place in the universe.
Okay, I want to shift gears for a moment and talk about the ethical considerations of exploring these ocean worlds. If we do find evidence of life, how do we ensure that we don't contaminate these pristine environments with Earth-based microbes?
Right, that's a crucial question, and it's something that scientists are taking very seriously. Spacecraft are rigorously sterilized before launch to minimize the risk of contamination. And if we were to send a lander or a submersible to Europa or Enceladus, the protocols for preventing contamination would be even more stringent.
So it's not just about exploring, it's about exploring responsibly and ensuring that we don't inadvertently harm any potential life we might encounter.
Precisely. It's a delicate balance between scientific curiosity and ethical responsibility.
Okay, I'm curious about your personal perspective on all this.
Mhm.
As someone who has dedicated their career to studying these ocean worlds, what excites you the most about the future of this research?
Well, what excites me most is the sheer sense of wonder and discovery. Every new mission, every new piece of data has the potential to completely overturn our understanding of the universe. We're living in an incredible time for space exploration, and I can't wait to see what we discover next.
Your enthusiasm is contagious,
Mm-hmm.
but let's be realistic. Exploring these ocean worlds is incredibly complex and expensive. What are some of the biggest challenges that scientists and engineers face in pushing the boundaries of this research?
One of the biggest challenges is developing the technology to explore these environments. We need spacecraft that can withstand the harsh radiation environments around Jupiter and Saturn instruments, that can operate in extremely cold temperatures, and robots that can navigate autonomously in alien oceans.
Those are some pretty tall orders. But it sounds like the technological advancements are happening at an incredible pace. Do you think it's realistic to imagine that humans might one day set foot on Europa or Enceladus?
It's certainly a dream, but not an impossible one. The challenges are immense, but human ingenuity and our drive to explore know no bounds. If we continue to invest in space exploration and push the boundaries of science and technology, I believe we can achieve anything we set our minds to.
That's an inspiring thought.
Yeah.
But for now, we'll have to content ourselves with the incredible data and images that missions like the Europa Clipper will send back to Earth.
Absolutely. And that data has the potential to revolutionize our understanding of the universe and our place within it.
Well, on that note, I think it's time to take a short break and reflect on all the amazing information we've covered so far. When we come back, we'll delve deeper into the philosophical implications of these discoveries and explore what it all means for humanity's understanding of our place in the cosmos. Stay tuned. Welcome back to our deep dive into ocean worlds. It's been quite a journey exploring these mind-boggling possibilities of life beyond Earth, hidden beneath the ice of moons like Europa and Enceladus. But before we wrap up, I think there's one more big question we need to tackle. Throughout this whole deep dive, I've been pondering why we're so drawn to these distant icy worlds. Is it simply human curiosity? This innate desire to know what's out there? Or there's something more profound at play?
I think it's a beautiful blend of both. We humans are explorers by nature. We have this unquenchable thirst for knowledge, this urge to understand our surroundings and our place in the grand scheme of things. But I also believe there's a deeper, more existential element to it. The search for life beyond Earth is, in essence, a search for meaning.
So it's not just about finding aliens. It's about finding ourselves, our place in the universe.
Exactly. If we discover that life arose independently on other worlds, it would tell us that life isn't a fluke, a random accident confined to our pale blue dot. It would mean that the universe is teeming with possibilities, that life might be a common thread woven throughout the cosmos.
And that would completely redefine our understanding of who we are and what it means to be alive in this vast, awe-inspiring universe. It would challenge our perception of ourselves as the only intelligent beings, wouldn't it?
Absolutely. Imagine the philosophical and theological discussions it would spark. We'd have to grapple with the implications of not being alone, of potentially encountering other intelligent life forms, perhaps even civilizations far more advanced than our own.
Those are questions that have fueled science fiction for centuries, but we're now on the cusp of potentially answering them for real. And it's all thanks to the incredible work of scientists and engineers pushing the boundaries of technology and exploration with missions like the Europa Clipper.
Every new mission, every new piece of data brings us one step closer to unraveling the mysteries of the universe and our place within it. And that's what makes this field so incredibly exciting. It's a constant journey of discovery, of challenging our assumptions and expanding our horizons.
And it's not just about the big questions, is it? The technology developed for these missions has incredible potential here on Earth, too.
You're right. The technologies we're developing for missions like the Europa Clipper have applications in everything from studying climate change here on Earth to developing new medical treatments. It's a beautiful example of how exploring the cosmos can benefit us in ways we might never have imagined.
It's like a ripple effect of knowledge and innovation spreading outward from our quest to understand the universe. As we wrap up this deep dive into ocean worlds, I'm left with a sense of awe and wonder. We've explored the possibility of life in hidden oceans, grappled with the philosophical implications of discovering alien life, and witness the incredible ingenuity of scientists and engineers pushing the boundaries of exploration.
And it's just the beginning. There are countless ocean worlds out there waiting to be explored, countless mysteries to unravel, countless possibilities to consider.
So as we sign off, I want to leave you with this thought. Keep looking up, keep asking questions, and never stop exploring. The universe is full of surprises, and who knows what incredible discoveries await us just beyond the horizon. Thanks for joining us on this deep dive into ocean worlds.